Hello, everyone. My name is Liad Rosenfeld. I'm a professor in the Chemical Engineering Department here at San Jose State, and I'm going to present to you what the Chemical Engineering Department is, what does it mean to be a student here at San Jose State and the Chemical Engineering Department, and I'm basically going to try and convince you to join us in the fall. So now I'm guessing that most of you are interested in engineering. So as engineers, we are problem solvers. Sometimes these are problems that you don't know that exist, but these are real life problems that we're solving. And the tools that we're using to solve these problems are math, science, economics, and many other tools. Now, these problems can be from a variety of fields such as disease, pollution control, finding new energy and fuel sources, worldwide lack of drinkable water, terrorism, and also demand for faster, better computers, smartphone, etc. So actually, in all of these areas, chemical engineering has some inputs. So now what is chemical engineering? Chemical engineering is the most versatile major. We, as chemical engineers, know enough mechanics to confuse the chemists. We know enough chemistry to confuse the mechanics, and we also know enough math to confuse ourselves. A chemical engineer can do a job of a mechanical engineer, a civil engineer, materials engineer, biomedical engineer, and so on. So that's why I'm saying that the chemical engineering major is the most versatile that you can find. It will open up a lot of opportunities for you, and you can focus on a certain field that you are interested in. So for instance, if you are more interested in materials engineering, there is a track that you can go towards emphasis on materials engineering. If you're more interested in energy or renewable energy or sustainability, there is a track that will cover that. So in chemical engineering, we are taking basic sciences such as math, physics, chemistry, and also biology, and we apply them to the conversion of raw materials into viable products. And we do that while we have to consider and be respectful for the environment. And we also do it in an economical, viable way. So we take innovative ideas that usually involve new technology, and we have to scale it up from a beaker size to production size. And we do that in an economically viable way. And of course, we also have to be considerate of the environment. So that is kind of a summary of what we do and what we learn in order to become chemical engineers. Now, traditional chemical engineering jobs are in the oil industry. So most people, if you'll tell them that you're a chemical engineer, they'll think that you work in the oil industry, because chemical engineering started from the need to refine oil. Afterwards, it evolved to also making some consumer products. However, nowadays, chemical engineering is so much more than that. So you can see chemical engineers in microelectronics industry, in microfluidics, in pharmaceutical, biotechnology, cosmetics, health products, energy, and renewable energy, and also materials, new development of new materials, and so on and so forth. So chemical engineers are needed in all industries. And since we also care about money, here you can see some numbers of the salaries for the different engineering disciplines, and these are the numbers for chemical engineering. Now I would like to talk a little bit about chemical engineering at San Jose State and about our curriculum. So the curriculum is math-based. We do require 3 calculus courses and 1 differential equations course to be completed before the students can start their core chemical engineering courses, which happens at junior year. So before junior year, the students will complete all their prerequisites, which are courses in chemistry, in physics, and in math. It will get harder, meaning that the courses will get harder. The hardest year is considered the junior year, and that is the year where the students start their core chemical engineering courses. So that is considered the hardest year. We do have support networks. So the chemical engineering department is fairly small. And it is small in a good way. It's small in a way that the professors know the students can walk into their offices and get advice from them. So it's kind of a family-like feeling in the department. So the course professors, again, they're very friendly. They are welcoming students into their offices. We do have academic counselors. So there is the chemical engineering major advisor that the students are required to see every semester. So every semester they will go to the academic advisor, they will go over the plan for the next semester, and they can also ask questions. We also have the Engineering Success Center that serves the whole College of Engineering, and that's also a resource for the students to go and to ask questions, and if they struggle, they can refer to some resources. We have some student clubs. So the AICHE club, the American Institution of Chemical Engineers, is a very active club. Most of our students are part of it and are participating in it. The AICHE club is organizing career fairs and tours to different companies around the area. It has a lot of activities in it. The student peers, so we do have a club room where the students usually use to do their homework and to meet with each other, and that will also form some kind of a network or supporting network for them to work together, to get some references, to have some friends maybe from older or senior year that will help the juniors. And then, of course, we really count on the support and encouragement by the parents. Apart from that, we do have some industrial internships and undergraduate research opportunities, and I'm going to talk about these two a little bit later on. Here is an overview of our curriculum. So we do have the general education, 21 units, and then we have also the prereqs, the math and science prereqs, again, 4 classes of math and 2 courses of physics. Then we have the engineering common area. These are courses that all engineering majors are required to take. Then we have the chemistry foundation. So we do general chemistry and organic chemistry. These are the foundations of chemistry. We do have the chemical engineering major courses. These are considered the core chemical engineering courses. Again, we start chemical engineering courses in the junior year. And then we have 9 units of electives. Electives are different tracks, and I'm going to talk about those different tracks. So basically, each student is asked to choose a certain track and then to follow the elective courses in that specific track. As for the elective tracks, so we do ask students to choose a certain track, and they have 9 units, 9 academic units that they need to complete in that track. We do currently have 5 different elective tracks. First one is biochemical engineering. Then we have the semiconductor. We have the environmental health and safety. We have the polymer ceramics processing, and we do have the energy, which is our last track. The Unit Operations Lab, which is done during the senior year, provides the students with hands-on experience on different unit operations that they study theoretically. So here you can see some examples of the experiments on condensers, fluidized beds, packed beds, and heat exchangers. Now for our senior project, which is our capstone course. So during the senior year, and it spans over the whole senior year, so 2 semesters, the students work in teams with industry advisors to conduct real-life industry-oriented projects. So here you can see some examples of the different companies that we're working with. Mango Materials is a startup company using methane to produce plastics. We do work with Genentech, with NASA, with PG&E, with Lockheed Martin, and again, these are just some examples of the companies that we're working with. So the students will work in teams. Each student will have their own role in the team, and they will have to operate together in order to be able to produce the product and to satisfy the client, which is the industry advisor. Here you can see some examples of the senior projects, of the different senior projects from previous or from the recent 2 years. So we do have 3 different projects from NASA. We have a project from Lockheed Martin on solid rocket propellant production. We are working with DuPont on some plant design analysis. We are working with PG&E and with EPRI. And again, these are just some examples so that you will see what are the different projects that are being offered during the senior year. A new program that I would like to introduce here is the Chemical Engineering SAGE program, stands for Spartan Accelerated Graduate Education. This program will allow outstanding students to complete a BS and MS degrees in chemical engineering in only 5 years. The application process will start during the junior year. The acceptance will be in the spring semester of junior year, and students who will be admitted to the program will start take graduate courses and will start working on the research project in the senior year of the bachelor degree, followed by another year in grad school. So this program is a great way for students who are interested in grad school to receive a master's degree in chemical engineering in only 5 years. Another major component of a program are internship opportunities that are being offered to our students in Silicon Valley top companies. Here you can see some examples of the companies that we're working with to offer internships. Usually students will get those internships during the summer between junior and senior year. And if they're doing well, then the company is going to offer them contract for after they graduate. And that's the path that a lot of our students are taking. Another important component of our program is undergraduate research. Each faculty in the department has their own research lab and research group, which is comprised of graduate and undergraduate students. The undergraduate students are encouraged to join a research lab and to participate in a research project that is suited for them. These research projects can serve as course credits for upper division electives, and they can also provide students with scholarship, and it will allow them to gain much needed hands-on experience in the lab. And that is probably the most important thing in a research project. Now, what I'm going to do next for the next couple of minutes, I'm going to go over the different research areas that we currently have in the department that will allow you to see a little bit of the activities that we are doing. So I'll start with my research lab, and my research lab is focusing on microscale flows or microfluidics and their applications in medicine and energy. We put a lot of effort in rapid detection methods of pathogens, which are viruses and bacteria. And the methods that we're using are droplet microfluidics and ITP, which is isotachophoresis. Another research area in my lab is prevention of hydrate formation in oil and gas pipelines. Dr. Ram's lab is focusing on bioengineering and mechanobiology. They're working on 2 main areas, microbial bioengineering where they are looking into novel methods to detection and diagnostics. Another research area in Ram's lab is vascular mechanobiology. Here, they're using microfluidics to study blood-related conditions, including blood clots and chronic fatigue syndrome. As you can see, many of the research areas overlap, and we have a lot of collaboration between faculty, so a student can work with more than one faculty as their advisor. Dr. Carr's lab is focusing on biomolecular engineering. They're using genomic tools in the form of metagenomic libraries, along with system biology and adaptive laboratory evolution to develop and apply genomic tools to the production of fuels and chemicals and to combat infections. Dr. Wagner's research group is focusing on sustainability and green energy. They're using experiments and simulations to study thermal analysis, fluidization, and pollution prevention. Dr. McNeil's research group is studying kinetics and catalysis, especially in biofuels. They're also developing new membrane materials. So as you can see from this short demonstration, we have a variety of research areas in the department, such that every student can find a lab that will provide them with research opportunities in the areas that they are interested in. That's it for the online presentation. I would like to thank you for taking the time to watch. You also have my email address here, so don't hesitate to email me if you have any questions. Stay safe, and we hope to see you all in the fall.